Now this may not be new to some of you, but when wiring up electric windows and similar things, especially on a classic car, you're often stuck with a switch like this one, which with which to choose up and down. And yeah, you've got a pair of them. This came out of the Gilburn actually, yeah, electric window switches, and they were pretty unusual back in the day to have electric windows. But by modern standards they are rather clunky. So what to do if you want something a little bit more, let's say, elegant than these big square things. For example, if you want to use a chromy switch like this, or one that's even smaller, or maybe a little square one, or in fact any kind of other switch other than these ones. But the point is, well, the question is, how do you make them work? So I thought it might be interesting to describe a fairly basic circuit really. So if we think of this as the window motor, and obviously to go up it has to spin one way, and to go down it has to spin the other way. And in typical form there's a wire each side, and depending whether plus is that side and minus that side, or minus is that side or plus this side, will make it rotate in the opposite direction, just like we want. So how to do that without using a horrible switch like that one? And it's all done, as it is in my case, in a lot of cases, with relays. In fact, this is almost set up for a very similar sub-project. And the way it's done, the way I always do it anyway, is to choose the common pole of a relay like this, so that the switched side can go to either up here or down here. So this is our relay now, and if we put one side over to 12 volts and the other side over to 12 volts, that's fine. That does nothing at all. 12 connected to 12, nothing happens. And then obviously 0 volts to 0 volts, and normally when nothing is happening, nothing will happen. But consider if you switch the relay switch downwards, now we have a circuit going 12 down to 0, and similarly if you switch the other switch, then we have a circuit going from 12 down to 0 in the opposite direction, and that's important. So having established that basically that's what this thing does, but being a relay of course, we have a nice little button, whatever we select, and that's connected to a 12 volt supply, and the output of that switch goes to the coil of the relay, then down to earth. And same on this side, so we've got 12 volt connection going via our nice little switch, whatever we select, and that goes similarly up to the coil of our relay and then down to earth. So now if we press our cute little chromy switch, in fact I've got one that's even smaller than this, press, and so we activate this relay, and now this relay switches position from here to here, and we have the circuit, and if we press this one we have the other circuit, so we have up and down. And that's pretty simple stuff actually. Maybe I'll just draw it out with a thinner pen just in case you didn't catch some of that. So again we have our, let's go and draw the motor. And the motor is connected to the common pole of a relay, and then there is a normally open and a normally closed connection on the relay. So this only works if you've got a 5-pin relay. They do have to be a 5-pin. Not all of these relays actually has 5. So this, as you can see, is a 5-pin relay, and the one so here is our coil connection. Doesn't actually matter which way up you wire this. So the coil is the coil you can see in there. It's an electromagnet. This is our common, and this is normally closed, so if you don't do anything, this relay isn't activated. There is always a connection between here and here. And this one is our normally open. That's right, now, yes, normally open. So if we activate this coil, then there will be a connection between there and there. So by activating the coil, we are connecting this terminal to here, either to there or to there. And that's exactly what we're looking at here. So once again, so if we draw, I'll draw it the slightly different way actually than I drew it a moment ago. So we have our normally closed, which is sometimes written as NC, because if you don't activate it, then it's closed. And the other side is the normally open. So NO, NO. In fact, if we were going to do the proper relay terminology, this would be pin 30, we haven't come to the coil connections yet. It's 87 and 87. Yeah, 87 is normally open. So that is 87, 87, and this is 87A. 87A. And then we have our nice cute little switch, which is going to pick, right, okay, so we're going to have our, I think we'll do it this way actually, 0 volts up there, 12 volts there, same here, 0 volts, 12 volts, and we will also have, in fact it might as well share the same connection, the 12 volt coming to our cute little switch that we've chosen because it looks nice, which is also normally open, and that activates the coil, which I'm going to show slightly out of line. That's the coil for the relay, and then down to earth. Let's see if I can do the other side slightly better. So we're going to go from sharing the 12 volt connection, coming into the cute little switch that we've selected, and then going to the coil, and then down to earth. So this would actually be on the because the relay is the whole thing. I'm going to draw a dotted line round. This is a relay here, and same thing here. So that's another relay, and the two connections to the coil, we have 85 and 86. So 85, 86, and we have 85, 86. So as I said before, if we press our cute little button that we've selected because it looks nice, it activates the coil, which magnetises this switch, making this close, so it moves from normally normally closed to the normally open position, because it's not normal, it's now abnormal because it's been activated. So normally open is now closed because we've activated the switch, and therefore we have a circuit running from 12 volts through the switch, through the motor, and through to the other relay, which is not activated, and therefore it's normally closed. And the motor runs in one direction, but if we do the opposite side and we let go of the switch, if we activate this one instead, our normally Closed changes position to become where the normally open is. This one is remaining as normally closed, and the circuit runs through here and out to 12 volts over there, and therefore the motor rotates in the opposite direction. So I've said the same thing twice, and hopefully somebody might find that useful. And to prove my point, if you like, here we have what I've selected for the Gilban, and here we have the little chromy switches which I kind of alluded to. Going to hear the motor running, which they look, you know, quite cute. In fact, we have a fifth one, 2 doors obviously, and the fifth one operates the boot release. And I think you'll agree that that is quite a lot more elegant than this horrible thing. Occupies the same amount of space, but just looks a lot nicer. So, in fact, the 2 relays are mounted inside the door, round about, just about in here, where there's a fair amount of dead space, and there we have it. So, I hope you'll agree that's quite an elegant solution to using nice little switches to do relative. Nice little switches tend to be quite simple on-off things, but using those little nice switches, simple ones, to do a relatively complex task. And the key to it is using 2 relays. Enjoy. If you got as far as this, thanks very much for watching. And in case you haven't already, please do consider subscribing. That would be really encouraging for me. So catch you on the next one.